fractions, the basics, multiply and divide. So again, let's reiterate this, go back over this. A fraction consists of natural numbers in the numerator, that's written above the fraction bar at the top, and the denominator written below the fraction bar or in the bottom. So the fraction bar, right, these things here, numerators are the 2 and the 3 in the top, right, above the fraction bar, and then the denominators are 7 and 4 below the fraction bar. A natural number, we use those for counting, 1, 2, 3, 4, 5. If you include 0, that means it's a whole number. That's a different set of numbers. Improper fraction, 19 over 4, that's where the numerator is larger than the denominator. A mixed number is the sum of a natural number and a fraction. So 4 and 3/4 means 4 plus 3/4. In algebra, it's much easier to deal with improper fractions. So for me in my class, I always want an improper fraction unless you are specifically told in the directions of the problem to use a mixed number. Okay? So improper fractions, use them unless you're specifically told not to. Now, if you're in someone else's math class, you want to find out what it is they want you to do. Okay? So when you multiply, the product of 2 or more fractions is the product of the numerators divided by the product of the denominators. So if m and n and p and q are fractions, then if I have m over n times p over q, if I multiply these two fractions, I just multiply m times p and n times q. All right? So m times p over n times q. All right? This also means that anything in the top, the numerator, can divide out with anything in the bottom, the denominator, because you remember you can only divide out when everything is multipliable. Guess what? That's exactly what you're doing here is multiplying. So the m can divide out with the n or the q. The p can divide out with the n or the q. It doesn't matter. You can divide out with anything in the numerator at the top with anything in the bottom of the denominator once you have it in multiply form. To divide, the quotient of two fractions is the first fraction multiplied by the reciprocal of the second fraction. Okay? And I remember this by keep, change, and flip. I had some students come in my class and say, Mr. Gus, my teacher says keep, change, and flip. And I thought it was the greatest thing. So I said, you know what? I'm going to remember that way too. Because I always said multiply by the reciprocal. And half my class is like, what's a reciprocal? That means flip it, right? That's the fancy word for flip it. So if m over n and p over q are fractions, and p over q is not 0, that's important. You can't divide by 0. We talked about that in a previous video. Then, it's undefined or not defined. So here, m times n divided by p times q. So keep in red. I'm keeping the m over n. I'm keeping it. Okay? And then I'm going to change my division to multiplication in purple. Okay? And then in green, I'm going to flip p over q to q over p. Right? So keep, change, flip. So m over n, change it, keep that, change the division to times, and then flip p over q to q over p. So m over n times q over p. And once you get to that point, then it's just the multiplication that we talked about above. So division of fractions is one step more than multiplication. So here, keep, change, flip, right? So perform the indicated operation and simplify. So here, you need to identify what you're doing first. So what am I doing with 3/7 and I have a dot and then 1/2? I am multiplying, right? Don't just blindly run into a math problem and go, hey, let me just do something. No, it never works. I mean, it might, but it's by accident. You always identify what you're doing before you start doing it, right? If you were going to cook a meal, you wouldn't say, okay, let me just start frying something. Well, what if you don't even need to fry anything? Then you just did something you didn't need to do. Right? Same thing with math. Do what you need to do here. Identify first. This tells me multiply. Once I know that, then I go, okay, I'm multiplying these fractions. And the way I multiply fractions is straight across. 3 times 1 over 7 times 2. And then nothing divides out there. Or I can just say, okay, 3 over 14. And then I could check it here and say, does it simplify? Does it reduce? Here, 3 and 14 don't have anything in common. So there's nothing to divide out. I like to check that over here. I like to say, does 3 divide out with 7? No. What about 2? No. And then 1's not going to divide out with anything. But 3 over 14 is your final simplified answer there. So we're going to work across here. 5/8 times 3/2. So if we look at this one, again, I'm multiplying. So I multiply straight across. I say 5 times 3, that's a times, All right, let me fix that all together there. Looks more like a minus than a times. 5 times 3 over 8 times 2. All right? So I look at this and go, okay, even before I multiply, that's what I do. I say, does 5 divide out with the 8? Nope. Does 5 simplify with the 2? Nope. What about 3 with 8? Nope. 3 with 2? Nope. So nothing divides out. That means when I multiply it, I should not get a fraction that reduces or simplifies. So let's look here. 5 times 3 is what? 15. 8 times 2 is 16. Do 15 and 16 have anything in common? And what I mean is, does anything divide out of both of them? No, it does not. Right? So if you're having trouble with the simplification and why I can or can't, go back and watch my video on simplify and reduce. Okay? It's fractions, the basics 1. Simplify and reduce. So here we have 8 times 3/9. So 8, now we got a whole number of times a fraction, okay? And some of you are looking and go, I can simplify that fraction. You sure can. So I'm going to remind myself that 8 is over 1. I'm going to remind myself that 8 is over 1. Now I have a fraction times a fraction. Again, I would never answer over 1. You would never tell me the answer, hey, the answer is 8 over 1. You would never do that. But you can think about it as 8 over 1. Now you say, okay, 2 fractions, I got 8 times 3 over 1 times 9. Does 8 divide out with 1 or 9? Nope. Does 3 divide out with 1? Nope. What about 3 and 9? Aha! And by the way, you could have done that here and said, wait, it divides out over here. But what goes into both 3 and 9? 3 goes into 3 once and 9 3 times. So now you have 8 times 1 is 8 over 3. You say, well, Mr. Guest, what if I didn't notice that? What if I just multiplied it, Mr. Guest? What if I just said 8 times 3 is 24, right? Over 1 times 9 is 9. Well, then if I get to 24 over 9, then I need to ask myself, hey, what goes into both 24 and 9? 3. 3. So then I would have to say, okay, this is 8 times 3 over 3 times 3, and the 3's divide out, and I'm left with 8 over 3, which is the same thing I have here, right? So either way is fine. I prefer to simplify it before I start multiplying because my numbers are smaller. Now, that right there is not that big a deal with 24 and 9, but you start getting some bigger numbers in math, and it can get out of hand in a hurry. So I always try to simplify before I multiply and check, but it's not wrong not to. So here, 5/4 times, again, what am I doing? Multiplying. So this is going to be 5 times 6 over 4 times 11. Now, does anything simplify before I just blindly say 5 times 6 is 30 and the other's 44, right? Well, look, does 5 simplify with 4? Nope. What about 5 and 11? Nope. What about 6 and 4? Aha! What do they have in common? 6 and 4 both have a 2 in common, right? So if I divide a 2 out of 6, how many times does 2 go into 6? 3 times. How many times does 2 go into 4? Twice. So now I have 3 and 2. All right. Now I don't ask myself, does 6 go into 11 because I've already simplified 6. I can ask myself if 3 goes into 11, but not 6 because my 6 is now a 3. I took a 2 out. So now when I multiply, I'm going to write this down. You don't have to show this step. 5 times 3 over 2 times 11, right? Because the 6 and the 4 are gone, right? They changed to 3 and 2. So this is going to be 15 over 22. You could do that in your head. In your head, I mean, as far as not writing that step down, okay? So 15 over 22, and does 15 and 22 have anything in common that divides into both of them? And the answer is no. So 15 over 22 is simplified, all right? Or reduced to lowest terms. So then what about 20? Let's see, what am I doing here? Again, I am multiplying, right? So 21 25ths times 20 over 7. So we're going to say this is going to be 21 over 25, 21 times what? 20 over 25 times 7. Now, if you want to, you go right ahead with your bad self and you do 21 times 20 and you do 25 times 7. And then you try to decide what divides out of both of them. Have fun with that, okay? So it can be done. It can be done. But again, I go back to, hey, does something divide out? Well, let's look at 21 and 25. Anything divide out there? Nope. What about 21 and 7? Aha! What do 21 and 7 have in common? They have a 7 in common. 7 goes into 21 3 times, and 7 goes into 7 1 time. So right now I have 3 times something over something times 1. Right? That 21 became a 3, and that 7 became a 1. What about my 20? Does my 20 divide out with something? What about 25? Aha, what goes into both of those? 5. How many times will 5 go into 20? 4, so that becomes a 4. How many times will 5 go into 5? 25. I just said it. It'll go into it 5 times, right? So let me fix that. That looks... So this is 5, and 5 goes here, right? So now 3 times 4 over 5 times 1. And by the way, just because I did that and crossed them up, that's not any kind of cross multiply, okay? So I've been teaching over 2 decades and never taught cross multiply, never will, all right? Again, that's something that's harder to know when and when you can't do it than to actually do it, all right? So I just don't do it. Work them the same way every time. So here, I divided them, but that doesn't mean I'm done. I still could have 3 could go into 5 or 1 or 4 could go in. And here, nothing else works, but you would still check it again to make sure. So then when I say this is going to be 3 times 4, it's going to be 12 over 5 times 1 is 5. And then there's another check right there. Do 12 and 5 have any common factors? The answer is no. So 12 over 5 is simplified. It's an improper fraction, but that's a beautiful answer. Leave it 12 over 5. Unless, of course, your teacher says, write it as a mixed number, and then you have to, okay? Because they're your teacher, and you should do what they say, all right? Nobody said you had to like it. My students don't like everything I ask them to do, but they do it if they want a good grade, right? So 7 over 8 divided by 2 over 5. So here, this is division. So how do we do division? We keep, we change, and we flip. So 7 over 8, we keep that. We change. What are we changing? The division becomes what? Multiply, and then we're flipping this to become what? 5 over 2. And now this one step, and it became a problem just like this one, right, where it's multiply. So now we say, okay, does anything divide out with the 7? When I do this, let's see. Let me write this. 7 times 5 over 8 times 2. Does anything divide out with the 7 and the 2 or the 7 and the 8? The answer is no. What about 5 and 8 or 5 and 2? Nope. So 7 times 5 is how much? 35. And 8 times 2 is 16. So now 35 and 16, do they have anything in common? The answer should be no if you've already checked. If you've already checked and didn't find one, then the answer should be no unless you overlooked something. But nothing else divides out there. And again, that's improper, but that's okay. For me, that's a great answer. Again, make sure you understand what your teacher prefers you to do. Okay? So what about 5 divided by 12 sevenths? Again, we have a whole number divided by a fraction, but anytime you have a fraction involved and you divide, I'm going to rewrite this and say, hey, this is over 1, right? I'm going to remind myself that's over 1. So it's going to be 5 over 1. I would never answer that, but I think about it that way here. And I'm going to keep, change, flip. So keep 5 over 1, change division to times, and flip this to 7 over 12. Okay? Flip it to 7 over 12. And then ask yourself, hey, does 5 simplify with the 1 or the 12? The answer is no. Does 7 simplify with the 1 or the 12? The answer is no. So then we multiply straight across. We're going to say 5 times 7. And I guess I've been doing that here on this step. All right. So 5 times 7 is what? 35 over 1 times 12 is 12. So 35 over 12. And again, 35 and 12 don't have anything in common. There's nothing else you can do. So this is simplified or reduced to lowest terms. All right. Again, an improper fraction. It's beautiful for me in my class, but make sure you understand what your teacher, professor, instructor wants and requires of you. So there's division. If it's division, I'm going to do what? Keep, change, flip. So I'm keeping the 7/5, and then I'm changing division to times and flipping this to get 10 over 3, right? And that's going to then give me 7 times 10 over 5 times 3. And by the way, if you can work it from here without rewriting it, that's fine. That's fine, okay? So here, does 7 over 5 simplify or 7 over 3? And the answer is no. What about 10 over 5? Oh, yeah, wait a minute. What goes into both of those? 5 goes into 5 once and 10 twice, right? So this becomes what? 7 times 2 is 14 over 1 times 3 is 3. And do 14 and 3 have anything in common? The answer is no. There's nothing that divides into both, no common factor. So your final answer is 14 thirds. Okay, again, an improper fraction. So let's just practice on this one. How many times does 3 go into 14? 3 goes into 12 4 times. And how far is 12 from 14? They're 2 apart. So that's 4 2/3. That's the mixed number for that one. What about 12 and 35? How many times will 12 go into 35? Well, 12, 24, 36. So it doesn't quite go into 35. It only goes into it 2 times. So this one is going to be what? 2 times with how many left over? It was 11 out of 12. So 2 and 11 twelfths is the same thing as 35 twelfths. This is just in case you're required to write these as mixed numbers. So let's go back to the purple one. 12 fifths here. 5 goes into 12 2 times, and there's what? 2 fifths left over? Right? So you keep your denominator the same, and you do, 5 times 2 is 10. 12 minus 10 is 2, so that's how you get the 2 fifths that's remaining. It's your remainder there when you divide. And then finally, this one up here in the blue, 35 over 16. 16 goes into 35 twice. That takes care of 32 of them, right? 2 times 16 is 32. So how many is left over if you took care of 32 of them? 3 of them out of 16. And by the way, when you write a mixed number, if that were 4/16, you would simplify it. But here, 3/16 doesn't simplify. 2 fifths doesn't. 11 twelfths, 2/3, none of those things simplify. So those are your mixed number answers that correspond to those 4 improper fractions. All right?